making about simple and compound interest. And we'll start with a simple interest problem. Suppose your bank has a savings account that offers a 2.5% annual simple interest rate. You make a $1,000 deposit, leave the money in the bank account for 20 years. Two questions: how much interest will you earn, and what will your final balance be? First of all, I should say that banks don't do this. They don't offer simple interest. But we need to understand simple interest before we're going to understand compound interest, because simple interest does form the basis for compound interest. So it is still worthwhile to think about this. And at a first glance, it does seem more logical for banks to do this. And what do I mean by this? What would be logical in terms of the amount of interest that you earn? Well, think about what's happening when you make a deposit. You are in essence giving the bank money, you are loaning them money, and they do use your money to make other investments for themselves. You are, in a sense, loaning the bank money. It does make some sense that they should pay you for the benefit of using your money. And it should be logical to you that that amount that they pay you, that interest that they pay you, should be proportional to, well, how much you deposit, this $1,000 here, how long it's in the bank, the 20 years right there, and finally, whatever the interest rate is. That's sort of the bank's margin of profit, you might say, that they are giving to you, your profit, off of what you are loaning to them. Sometimes the interest rate is low, sometimes it's high. I'm making this in 2013. The interest rates are very, very low right now, but I remember about 30 years ago they were pretty high. So interest rates do fluctuate over time. They are pretty much determined by supply and demand. They are trying to attract customers when they raise the interest rate, and when they don't need to attract customers by having a high rate because perhaps other people are not having a high rate, then they give you a lower interest rate. It also is affected by what they can earn off of your money. So what do I mean by proportionality? Let's write down an equation here. We're going to let we're going to let I, capital I, represent the amount of interest that you earn. I'm going to let P represent the principal, the amount you deposit at the beginning of the time period. I'm going to let R be the interest rate and T be time. It is important that the units for the interest rate as a percent per unit of time do match the units for the time. Usually time is measured in years, so the interest rate would be a percent per year. Sometimes, though, time could be measured in months or even weeks, and then the interest rate would be a percent per month or a percent per week. This basic equation, which I will put in this Word document here and make bigger for you, is showing a proportional relationship between I, the amount of interest you earn, and each of these three quantities, P, the principal, R, the interest rate, and T, the amount of time. If you hold any one of these quantities fixed, for example, the principal, say $1,000, and the interest rate, say 2.5%, and allow the time to vary, think of this as a function of time, then if you double the amount of time that you keep it in there, you'll double the interest rate. You'll double the amount of interest that you earn. If you triple the amount of time that you leave the money in the bank, you will triple the amount of interest you earn. On the other hand, for example, if you keep the interest rate R and the time constant, R say at 2.5% and T at say 20 years, then I is directly proportional to P. If you double P, the amount you deposit, you'll double the interest that you earn. If you triple P, the initial deposit, you will triple the interest that you earn. So again, this is the basic equation that we will now use to do this basic calculation to answer these questions, and we'll go a little further and also do a little functional modeling to see graphically what I just said verbally a minute ago. So let's see. We can get Excel to do this basic calculation to calculate the interest we earn with a formula. In fact, it might be good to put these quantities in here, P, R, and T. Put the values that I have here, $1,000 for P, 0.025, 2.5% for R, and 20 years for T. And I'll go ahead and calculate I over here, the interest, using the formula from the Word document. Using a formula in Excel, you need to put an equal sign first, and then you put the cell references. B5 times B6 times B7 will calculate that product. But this is something that you should be able to do in your head. 2.5% of 100 is 2.5, so 2.5% of 1,000 would be 25. And then multiply that by 20. 25 times 10 is 250. So 25 times 20 would be 500. This should be a 500 here, but you can also check it with your calculator. Indeed, it is a 500. Again, the benefit of using Excel, I'm assuming you've had a little bit of experience with Excel, by using the formula that I typed in this way, equals B5 times B6 times B7, I can now change the numbers over here, and I can see, for example, that if I double the amount of time from 20 to 40, the interest will double from 500 to 1,000. If I double the principal, well, let's triple the principal from 1,000 to 3,000, the interest will triple from 500 to 1,500. Also, if I double or triple or quadruple the interest rate, let's quadruple it to 10%, the interest will quadruple from 500 to 2,000. So that's where that direct proportionality is coming in. We're seeing it in how we change those quantities affecting the total interest that we earn. So the interest that we earn for the question is going to be $500. What will your final balance be? That would be the initial principal plus the interest. And in Excel, I can just do an equals B5 plus E5 here and get 1,500. And again, if I make changes, both of those things will now be updated. If my principal was 2,000, my interest will double to 1,000, and my final balance will be 2,000 plus 1,000 is 3,000. There we go. Etc. You can experiment with that to see what happens. But we've answered these two questions. $500 is the amount of interest you earn. That's the extra amount that the bank gives you over time. And $1,500 then would be your final balance after 20 years. I'll end this video by just showing you this proportionality in graphical terms. Let's think of the interest as a function of t, time. So we'll make two graphs, one for the interest that we earn and one for the final balance, p plus I, sometimes called A, the accumulated value. I will let time increment up. Let's not do it by years. Let's do it by every half year, let's say. Every 6 months, I'm going to take what's an A10, the 0, and add 0.5 to it. And by using that formula, I can copy and paste, click and drag on downward here. I won't go down to 20. Let's stop at 10. Almost there. There we go. I can now use the interest rate to find the interest. I can use these three quantities. If I want to copy and paste these cell references down, though, and have them stay fixed, I need to use dollar signs, technically speaking, just in front of the numbers, not in front of the B, but I will put it in front of the B anyway. In effect, around the B, $B, $5 times $B, $6 times $B, $7. It is enough to just use the second dollar sign in these because we're wanting to keep the rows fixed. But I will, just to be safe, use double dollar signs like I've just shown you here. That keeps the cell references fixed if I copy and paste downward. Oh, you know what? I realize I made a mistake here. I don't want one of those references to be fixed, just the first two. $B, $5 times $B, $6 times B7, times A10. I want to be something that changes the time. The time is in cell A10, as I copy and paste this formula downward, I want that to change. I want that to get updated so that I do get $0 of interest if I have the money in there for 0 amount of time. If I have the money in there for half a year, I get $12.50 of interest. For a full year, it's $25, etc. You can see the proportionality coming out. If the time gets doubled from 1 to 2, the interest gets doubled from 25 to 50. Let's keep going on down here. And then I can add on the initial deposit to these things. B10 plus $B $5 will keep the B5 fixed and the B10 not fixed as you copy and paste downward, and that's what you would want to get the final balance as a function of time. And then we could graph both of these functions, highlight everything, go up to charts, and scatter, and I'll just connect this. So it's going to be a straight line. I could use either one. And without bothering to label these graphs, I guess Excel did. I is the interest. It's a straight line through the origin. That's because it's a proportionality. P plus I, which equals A, the accumulated value, is still a straight line, but not through the origin. That's technically not a proportionality between T and A because it doesn't go through the origin, but it is still straight. And that'll be the end of this introductory video.